find the probability of getting 53 Sundays in a leap year. Find the probability of getting 53 Sundays in a leap year. Okay. How will you get 53 Sundays in a leap year? First of all, whether a leap year or non-leap year, how many Sundays are there in a year? Number of days in a leap year is 365. In a non-leap year, it's 365. In a leap year, it is 366. Whether 366 days or 365 days, how many weeks in a year? In a leap year, there are 366 days, right? Which is 52 weeks, isn't it? Even in a non-leap year, right? There are 52 weeks. Okay. Whether number of days is 365, but even in a non-leap year, it will be 365 days. 52, it will be 365 days and 52 weeks. That means if there are 52 weeks, you're definitely getting 52 Sundays. So whether a leap year or a non-leap year, each year contains 52 Sundays, right? But we are looking for a leap year in which has 53 Sundays. So, but 52 Sundays means how many days have gone? 52 Sundays accounts for how many days? 52 into 7, right? Which is 364 days. Right? 52 Sundays means 52 into 7, which is 364 days. Where are the other 2 days gone? Right? Now, how many days remaining in a leap year? Number of days after 52 Sundays, how many days remain?
2, sir. 2 days.
2 days. In a leap year. How many days remaining in a leap year? We have 366 minus 364, which is 2 days, right? Now, in these 2 days, if you have one Sunday, then you will have 53 Sundays in total, because already there are 52 Sundays, right? Already there are 52 Sundays in 364 days, right? Now, in these 2 remaining days, if you have one Sunday, right, then you can have 53 Sundays in a year. So, what are the various possibilities? So what is the sample space? In these 2 days, what can be the various possibilities? Either this day can be a Sunday and a Monday, right? Or this day can be a Monday, Tuesday, or this can be a Tuesday, Wednesday, or this can be a Wednesday, Thursday, or this can be Thursday, Friday, or Friday, Saturday, Saturday, Sunday, isn't it? These 2 days can be any of this. So how many possible outcomes? Total number of possible outcomes? Total number of possible outcomes, if you count these, you'll get 7, right? Now, if I say let E be the event, there are 53 Sundays in a leap year. Okay. Then what should be this set E? What are the favorable outcomes? Because I must have, out of these 2 days, I must have one Sunday. So what are my favorable outcomes? This one and this one. It must have one Sunday, right? Sunday and a Monday, or you can have a Saturday and a Sunday. If any of the if out of the any of the 2 days, you must have one day as a Sunday. So I can either you can have a Sunday and a Monday combination, or you can have a Saturday and a Sunday combination, isn't it? So number of outcomes favorable to the eventee. How many? There are two. Hence, probability of the eventee, or there are 53 Sundays in a leap year, is equal to 2 by 7. And that should be your answer. Okay. Any question? Let's move to the last question that I have selected for you. Okay, this question here is from a pack of 52 cards, all cards whose numbers are multiples of 3 are removed. Right? A card is drawn at random. What is the probability that the card drawn is what is the probability that the card drawn is a face card? Second question is an even number card. Okay, an even numbered card. And the third question is an honor card. Okay, so let's see. From a pack of 52 cards, all cards whose numbers are multiples of 3 are removed. Now in a pack of cards, what are the numbers? Ace is there, right? King, queen, jack, right? And then you have 2, 3, 4, 5, 6, 7, 8, 9, and 10, right? These you have, right? Okay. And this you have 4, right? You have a second suit, you have a third suit, and you have a fourth suit, isn't it? So you have 4 suits like this, right? This is the entire pack of 52 cards. Now from this, cards whose numbers whose multiples of 3 are removed. So which cards are removed? So from here, 3 is removed,
So 3,
6,
6,
6,
and 9.
9 is removed. Okay. Similarly, from here also, 3, 6, and 9 is removed. Let's say this is, let's name each of the suits as they are. Okay. Let's say I have this as my hearts, this has my diamonds. Okay. Uh, this has my clubs, and this has my spades. Okay. So from each one, I am removing multiples of 3. Okay. So I've removed all this. Okay. Now once I have removed, now after removing, a card is drawn at random. Okay. So how many total number of possible outcomes here? Total number of possible outcomes. Total number of cards is 52, right?
But
And how many cards am I removing?
40 outcomes.
Yes, 52 minus. How many cards am I removing? I'm removing
So
12.
12.
So 40 total number of possible outcomes are there, right? Instead of 52, 40, because before drawing a card, I'm removing all the cards with even numbers on them, right? Next, first question is, what is the probability of getting a face card? So I call this event E1. Let E1 be the event a face card. Okay. So number of outcomes favorable to E1. To E1. How many face cards that are there in this? All the face cards are
So
available,
12
right?
face cards are there.
Yes, all the face cards are available, right? So 12. So hence, what is the probability? Hence, PE1 or probability of a face card is 12 by 40, which is 3 by 10. Okay, that answers the first question. Let us see the next question. We define our event E2. What is the next question here? An even numbered card. Even numbered card. So number of outcomes favorable to E2 is even number. How many
So
even
12.
numbers are there? In each suit, you have 2, 4, um, you have,
So 2, 4, and 8.
yes, 2, 4, 8, only 3 even
And
numbers in
10.
each suit, right? And there are 4 suits. So how many even, how many outcome favorable to the event E2? 3 into 4, right? 3 even numbered
So
cards in
10
each.
also.
10 is also there. Okay, then I have 4. Yes, then I have 4, right? So 4 into 4, 16. So I have 4 even numbered cards in each suit, and because there are 4 suits, there will be a total of 16 even numbered cards, right? Hence, PE2 or probability of an even numbered card is 16 by 40, 2 by 5.
Yes, sir. 2 by 5.
And finally, third question was an honor card. Let E3 be the event and honor card. Okay. So number of outcomes favorable to E3
So 4. No,
Why
sir, no,
4?
sir, no, sir, not 4.
There are 4. How
Plus
many cards?
16.
Yes, there are 4. These 4 are your honor cards, right? So, and in each suit you have 4 honor cards. That means there are 16 honor cards. 16. Hence, what is the probability of an honor card? Probability of E3 or probability of an honor card? 16 by 40, right? This is also 2 by 5. Okay, so that's it. And one more definition, last definition is, I told you the definition of an impossible event, right? Remember impossible event? What is an impossible event?
Yes, sir.
An event which can never occur. An event which can never occur. That is an event whose probability is 0. Is called an impossible event. Okay. Example of an impossible event. In the casting of an unbiased dice, if what is the sample space? One, two, three, 4, 5, 6. Now in this sample space, if I define the event E as, let E be the event, appearance of 7. Appearance of 7. Can 7 appear in the casting of an unbiased dice? 7 cannot appear, right? Because we have numbers
Yes,
only
sir.
from 1 to 6. Therefore, E is a null set, right? Therefore, we write probability of E is equal to 0. Here, E is called an impossible event. Right? Next, last definition is that of a sure event. An event that is sure to occur. Sure to occur. That is, whose probability is 1. That is 100% it will definitely occur. Whose probability is 1. Is called a sure event. Okay. Example of a sure event. In the tossing of a fair coin. What is the sample space?
So H and T.
H comma T, right? Now, on this sample space, if I define this event, let E be the event, appearance of a head or a tail. Right? Therefore, what is the event E? Equal to the sample space, isn't it? That means if I'm tossing a coin, I'll definitely get a head or a tail. I cannot get any other. I cannot get a face if I if I'm tossing a coin, I cannot get a face, right? I'll either get a head or a tail. I cannot get a body, isn't it? I cannot get a B if I toss a coin. If I defining
Yes,
the
sir.
event as head or tail, definitely I'll get a head or tail. See, if you are appearing for an exam, if I tell you you will either pass or fail, isn't it? That is sure to occur. If you are sitting for an exam, you will definitely either pass or you'll fail, isn't it? So what I am talking about is as a sure event. So therefore, PE here we say, because E is equal to the sample space, we say probability of the event E is equal to 1. Okay. Here E is called a sure event, right? Now, if I ask you one
Yes, sir.
question, in the tossing of a coin, if I define the event E as E1, let's say, as appearance of a head, is this a sure event? Is E1 a sure event?
No, sir.
No, because a tail can also occur, isn't it? So that is why here, when I'm defining the events as appearance of head or tail, it becomes a sure event. Because here, E1 here is how much? E1 here is only one element in this, right? Which is
Sir,
actually
it becomes
which is,
half.
which is only a subset of the sample space, isn't it? Right? Yes. So therefore, if you're going to write the probability, then the probability of E1 will simply be half. Okay. So that is concludes your chapter on probability. Okay.